Hi, my name is Richard Wyborg. I'd like to show you a new bracket set that I've just completed. It's a quarter scale model from one of the greatest wooden buildings in the world, still existing. It's in China, built nearly 1,000 years ago. It's an octagonal pagoda that's 160 feet tall. It has 54 different kinds of brackets, and I've chosen one to make this quarter scale model. So I'd like to give you a little background just to show you a picture of the building. So you can see there's many layers to it, and then this is a close-up photo of the corner bracket set that I've made. And being an octagonal building, the joining is a little bit different from a normal rectangular building. The bracket set rests on a round column. It has tie beams and a plate, and then a base bearing block on which everything rests. So all the load of the roof that's resting on the bracket set is concentrated down onto the wooden column. So there's some interesting things about this bracket set that are new to me. One is that the purlins and the beams and the arms all cross at 45 degrees instead of 90 degrees. And certain of the details, for example, the ends of the bracket arms are shaped at a 45-degree angle instead of 90 degrees. So this is quite a bit of extra work, and it was done not to save time, but to imbue the bracket set with a certain kind of beauty. One other detail is usually the bearing blocks are square or rectangular, but this one has bearing blocks that are made at a 45-degree angle. When you look at it from the ground at a building, it's this big cluster of pieces that look interesting, but I want to show you what a couple of the pieces actually look like. So this is the main base bearing block on which the whole bracket set sits. So here you can see the crossing for the two wall plane lines, and then intersecting that is what I call the hip line. How it goes together. Okay, so these are the two first level tier 1 bracket arms, and then this is the hip line piece, and you can see it's shaped to lock into the main bearing block and to notch into the crossing arms. The bearing blocks and the filler piece form a plane across the top. Okay, so this is then the first tier complete. You can see the 45-degree angle on the end of the arms and the bearing blocks. And then it goes up to tier 2, tier 3, tier 4, and tier 5. And on top of that go rafters. Most of the bearing blocks, the bracket arms rather, are a simple half lap crossing joint with a notch through for the hip piece. So we'll set this guy in here. Okay. And then this is the second tier, and the hip line piece set in place. And then this is the third tier. Crossover. So again, the center of the column is the center of all the layout. So this is where the two theoretical wall planes meet. And there can be parallel rows outboard and inboard, which we will see now. So this is quite an interesting piece, you know, loaded with bearing blocks, a lap joint here, another lap joint here with a channel through for the hip. And then the mating piece. Like this. Okay. Each tier becomes a little bit more complicated than the one before it. And this then is the hip piece for the third level tier. And again, it has the crossing of the two bracket arms here, and a crossing for bracket arms up above as well. And I'll just throw this together here if I can. Okay, so this is the third level complete. In some case, so there's a variety of bearing blocks, the large one, the smaller ones, the diagonal ones, and the flat top ones. Back here. So one very important thing to point out, when you make a bracket set, it seems like sort of an organic unit of pieces. It's also a kind of almost like macrame. It's weaving together various tie beams that connect to the next bracket set. And actually the system of tie beams wraps around the entire building. So if I turn this around, we'll see that anything with kind of a square rectangular cut, such as these pieces, are all tie beams, so they're long and they connect to the next bracket set. So it's only cut short here as a matter of convenience of being able to build something and move it around. So then the final pieces are the level 4, level 5 here. This is the hip. It's actually two pieces, the lower and the upper, and it notches on here and is held in place by gravity. In Chinese timber frames, all of the joinery is just wood-to-wood connection, but in fact they do use nails to nail the rafters to the purlins. So the rafters that would sit, if this were to be a rafter and it would rest on these purlins, it would be nailed to the purlins. So this is my journey back to the year 1056, and my way of communing and enjoying the spirit of the pre-industrial age, when things were done with muscles and sweat, and the ultimate aim was to create something that's inspiring and beautiful. And so I hope you enjoy seeing what fellow builders and carpenters were able to do 1,000 years ago.